Okay, hi everyone. Today we are looking at the second type of mathematical induction question where we need to prove divisibility. So on the side here, I just wrote something that we are going to use in all of these proofs. I'm sure that we all know that if a number is divisible by 3, for example, and this 3 obviously can be any number, but if a number is divisible by 3, then it can be written as 3 times p, where p is a natural number. So now what I mean by that is if you take, for example, 27, right? I'm sure we all agree that 27 is divisible by 3. So now 27 can be written as 3p, where p is equal to 9, right? Because 3 times 9 is 27. Now, if any number is divisible by 3, then that specific number can be written as 3 multiplied by a natural number. Okay, if this number had been 30, then it would be 3 times 10. If this number had been, 90, then it would be 3 times 30. All right, so any number that is divisible by 3 can be written as 3 multiplied by a natural number. And we use p to just represent that natural number. Okay, that's what we're going to use in these examples. You can use a number or a letter other than p, but I'm just going to be working with p all the way through. That's what they do in the answer series book as well. Okay, so we're going to jump straight into these examples. The nice thing here is that we're going to use exactly the same steps as in type 1. Our actual algebraic manipulation is just going to be slightly different. But I mean, that's the case in all of the type 1 questions anyway. That algebraic manipulation is always slightly different. Now, in this case, it's also going to be different. Okay, so we're going to jump straight into this. Use mathematical induction to prove that the expression n cubed minus 4n plus 6 is divisible by 3 for n an element of natural numbers. Okay, so what we're going to do is step 1, we're going to write down required to prove. Remember, the required to prove part is where we need to rewrite what is written here. This expression is divisible by 3. We need to rewrite that in mathematical terms. So we're going to say n cubed minus 4n plus 6 is equal to 3p, where p represents any natural number. Okay, that is what we need to prove. Our second step is where we're going to prove this for n equals 1. All right, so step 2 is for n equals 1. And now, instead of doing the left-hand side equals right-hand side thing, I'm going to do it slightly differently. I'm just going to sub in 1 into this expression and see whether the number that I get is actually divisible by 3. Okay, so I'm just going to say 1 cubed minus 4 times 1 plus 6. Okay, so if we work that out, we do actually get an answer of 3. Now what I'm just going to say is I'm just going to write in words, which is divisible by 3. Therefore, true for n equals 1. Okay, that is the way that the answer series book does it. They write this out in words. They also do it in the same way in the old syllabus textbook, which you are still going to get on your first day back at school. If you wanted to, you could write it differently. So you could write it like this. I'll do it in pink on the side. So you could have 1 cubed minus 4 times 1 plus 6 equals 3. And then from there, you could say equals 3p, where p equals 1. Okay, because you stated that whole 3p thing in the first step. So instead of writing which is divisible by 3, you can write it like that as well. I'm going to follow the way that they do it in the textbook because the solutions will also be written out in that way. You are going to get a solution book as well. So yeah, it's up to you. You're more than welcome to write it like this. Okay, you won't lose any marks for doing this. I'm just going to follow how they do it in the textbook. Okay, so it's true for n equals 1. The next step would be to assume true for n equals k. Right? Assume true for n equals k. So now we're going to say k cubed minus 4k plus 6 is equal to 3p. We don't have to state again that p is an element of natural numbers because we stated it there in the first line already. Okay, so we assume that this is true again so that we can use it in our next step. So now I'm going to say 4 n equals k plus 1. Our expression now, this whole expression, I'm just going to rewrite it actually so that we have it. Okay, I'm now going to substitute k plus 1 wherever I see n. So I'm going to have k plus 1 cubed minus 4 times k plus 1 plus 6. Okay, and I need to prove that that is equal to something with a 3p or something that is divisible by 3. Now, what I want you to notice is that we have this line up here, this expression is equal to 3p. And from the previous questions, I hope that you remember that you always have to take the previous statement that you assumed was true. You need to have that statement in your next step, in your n equals k plus 1 working, so that you can substitute it with the 3p. Now, as it stands here, we don't have k cubed minus 4k plus 6. So we are actually going to have to multiply these brackets out, group the terms together so that we have k cubed minus 4k plus 6, and then after that, substitute it with 3p from there. Okay, so that is the next thing that we're going to do. I'm just going to write an equals here to show that we are carrying on with that. So we are then cubing it. You can do it in the long way. You can do k plus 1 squared and multiply it out. Or there is a shortcut for cubing a bracket. So it's up to you how you want to do that. So it is going to simplify to k cubed plus 3k squared plus 3k plus 1. All right, that's k plus 1 cubed. Then we're going to multiply negative 4 in here. So that's going to give us minus 4k minus 4. And then we have our plus 6. Now let's notice that we have a k cubed, we have a minus 4k, and we have a plus 6. Okay, so in the next step, we're going to group those terms together. So we're going to say k cubed minus 4k plus 6. And let's just take a look at what we're left with, because we might have some like terms within that. So we have plus 3k squared plus 3k. And then here we have plus 1 minus 4, which is minus 3. Now we have that underlined expression, which in the next line, we are actually going to substitute for 3p. And what I want you guys to notice is that I kept that in mind right from the start, which is very important, because if you were just going along, just multiplying out and simplifying, you might have missed that plus 6, because you probably would have said, okay, there's k cubed, there's a 3k squared, there's a 3k and a minus 4k. I can simplify that to minus k. And then there's a 1 minus 4 plus 6. I can simplify that as well. Okay, if you had done that, that's not wrong. But then you wouldn't end up with these 3 terms, which are the 3 terms that we actually need in order to use our previous statement that we assumed was true. Okay, so please, right from the start, keep that in mind. Please remember that you need to use the k cubed and the minus 4k and the plus 6. Group those terms together right from the start, and then substitute it for 3p. Okay, instead of simplifying this whole thing and then having to split the terms up afterwards in order to get these ones. Okay, so now we're going to go on and we're going to use 3p for this. Now, what I want you guys to notice, remember we're looking for something that is divisible by 3. Do we notice that with these last 3 terms that we actually have left, right, there is a 3 in each of those terms, all right? Each of those terms are actually divisible by 3. So we can take 3 out as a common factor. Basically, we're grouping these 3 terms together. First, we group these 3 together so that we could use 3p in their place. Now we're grouping these 3 terms together so that we can show, so that we can take out 3 as a common factor so that we can actually show that that is divisible by 3. So we're going to say plus 3. And from there, we'll be left with k squared plus k minus 1. Right? Now, remember we need to show that this expression is divisible by 3. So if we notice here, if we look here, again, we have 3 as a common factor in both of those terms. So now we are in the next line, again going to take out 3 as a common factor, and we're left with p plus k squared plus k minus 1. Now remember that p is a natural number. K is also a natural number, right? Because we're working with all natural numbers here. So p is a natural number, k is a natural number. So this whole expression will also be a natural number. Okay, this whole expression is also a natural number. So what did we prove here? We proved that when we substitute k plus 1 for n, we can actually show that the whole expression is equal to 3 multiplied by a natural number. And that is what we said in the beginning. If a number is divisible by 3, it can be written as 3 multiplied by a natural number. Okay, so we've actually proved it. So now we're just going to say which is divisible by 3. And there we go. We've actually proved it. Now we just have to do that whole thing again. So therefore, if true for n equals k, then true for n equals k plus 1. Since true for n equals 1, then true for n equals 2, n equals 3, etc., or and so on. It's up to you. Therefore, true for n element of natural numbers. Okay, so that is the first example. I hope it's not too confusing. It's exactly the same steps. Like I said, our algebraic thing is just a bit different. Okay, I'm going to do another example, one that is quite tricky. There is an extra example in the answer series book, which I will share on the group, and you can copy that down if you want. I'm going to do, so this is the first example. The second example, I'm not going to do step by step. The third one I am, but I will share the second one. So the second example, I wonder if I'm going to fit it all onto one page. Okay, I'll try my best. So again, so it doesn't actually say by mathematical induction, but yeah, in a test or exam it will. Prove that a to the power of n minus b to the power of n is divisible by a minus b for n element of n. Now, what makes this question a bit more complicated is the fact that we're not working with numbers. Okay, so we're not going to have a 3p. Okay, in this case, we're actually working with only variables. Okay, which is a bit more complicated, but we can do it. Okay, so the first step is RTP. So we're going to say a to the n minus b to the n is equal to, and now we would have written in the previous example, we wrote 3p, where p is an element of natural numbers. Now it's going to be this times p. But because I prefer having the single term thing on its own, not term, but you know what I mean, the single variable on its own. I'm just writing it in front, but you could have also written it as a minus b in brackets and then the p at the back. Okay, and we have to just say that p represents a natural number. Okay, that's what we're trying to prove. Next step, for n equals 1. This expression, all right, a to the 1 minus b to the 1 is equal to a minus b, which very obviously is divisible by a minus b. What's a minus b divided by a minus b? Anything divided by itself is just 1. So there we go, which is divisible by a minus b. Therefore, true for n equals 1. Next, assume true for n equals k. So then we have a to the k minus b to the k is equal to p times a minus b. All right, so that is now what we assume is true. Now again, guys, in our next working, before I'm even writing that down, let's just make sure that we all remember that this is what we're going to be looking out for. We're going to have to try and write whatever we have on the left-hand side in terms of this. These two terms, I'm going to have to group together so that I can substitute it with this. Okay, so now for n equals k plus 1, we're going to have a to the k plus 1 minus b to the k plus 1. Okay, this we need to try and write in terms of this. Okay, so equals, first thing that I'm going to do, because I just want a to the k and b to the k, I'm going to split these two up. All right, we did this quite a lot last year when we worked in exponents. So a to the k times a to the 1 minus b to the k times b. Okay, we've done that now. Now, what can we do to split these things up? It's a bit more complicated. What we're actually going to do is we're going to apply a trick. All right, we are going to, it's similar to what we did with completing the square, where we added b over 2 squared and then we subtracted it again. All right, as a trick to introduce some terms that we need in order to manipulate the expression that we have. But if you're adding something, you can't just add it out of the blue. You have to add it and then subtract it. Okay, so we need to think, what can we add and subtract to this so that we can, I don't know, maybe factorize, maybe take out some common terms so that we can eventually end up with a to the k minus b to the k. Right, now it might be a bit difficult to see that in the beginning because this is the first example, but we're actually going to add and subtract a times b to the k. All right, so I'm going to show you how I'm going to do that. I have a to the k times a. Now I'm going to add a times b to the k, and I'm going to subtract it. But then remember that we also had this. Okay, so this is the trick. We are adding something that will help us, but because you can't just add it, you have to subtract it as well. All right, so I'm adding it and I'm subtracting it. Now let's see, can we now possibly group these terms together so that we can take a common factor out, which will help us. Now, if we take out a from these two, all right, because we do see that we have an a in both of them, we can take out a as a common factor, and then I'll be left with a to the k plus b to the k. All right. If we take out minus b to the k here, I'm going to be left with a plus b. That doesn't help me. Remember when we factorize by grouping, we have to group terms together so that the bracket that we're left with is a bracket that we can take out as a common factor, all right? So what if we group together these two? We can take out an a from both of these as well, all right? So if I take out a as a common factor from here, I'm going to be left with a to the k minus b to the k. That's good. That's what we want, right? So I'm going to say that again. I can group these two terms together. Let me actually just erase this so that we can underline these terms. Okay, so I'm saying that if we group together a to the k times a minus a times b to the k, all right, we could possibly group these together. We could take out a as a common factor. Then we'll be left with a to the k minus b to the k, which sounds promising because we want that, all right? Which means that I would have to group these two together. And if I do that, I'm going to be left with, or I'm going to have to take out as a common factor b to the k, which will leave me with a minus b. Now, those two brackets aren't the same, but remember, if we can get this as a bracket, we can actually replace it with p times a minus b. And then I'm going to get an a minus b bracket from this one, which means that actually after doing the substitution, after doing the replacement, I suppose, we will have a common bracket. Okay, so I'm just going to rewrite that by grouping them together. So I'm going to take a to the k times a, and I'm going to group it with minus a times b to the k. Right, I'm grouping those two together. And then I'm going to group together a times b to the k minus b to the k times b. Right, if it still doesn't make sense to you, just look at what happens afterwards. Hopefully it will. So here we're going to take out a as a common factor. We're left with a to the k minus b to the k, which is what we have up there. Meaning in the next step, I can rewrite this as a times p bracket a minus b. So I'm going to have an a minus b bracket. Here I'm going to take out b to the k as a common bracket, and I'm going to be left with a minus b, which once we do the substitution here, that a minus b bracket is going to be a common factor. And remember, we're trying to show that this expression is divisible by a minus b, which is wonderful because if we can take a minus b out as a common bracket, that means that it is a factor of both terms, meaning that the whole expression is divisible by that bracket, a minus b. Okay, so here I'm going to say jumping the gun there a bit. Just erase that. I'm going to say a times p bracket a minus b. I'm now doing that substitution over there. Plus b to the power of k, a minus b. A minus b is a factor of both of these terms, so I can take it out as a common factor. A minus b. From the first term, I'm left with ap, and from the second term, I'm left with b to the k. All right, p is a natural number, k is a natural number. A and b here also represent natural numbers because that's how it was given, all of them, those variables. So what does that mean? If I can take a minus b out as a common factor, then obviously this whole expression is divisible by that factor, a minus p, which is divisible by a minus b. Fantastic, we've proven it. Okay, we did prove it with the help of a trick, which is very important, which you probably would not have thought of doing. All right, so please be aware of this, that if you're stuck with something where you really can't actually do anything, but you know you're looking for that, you might have to do this kind of trick where you're adding and subtracting the same term in order to manipulate it so that you can get to the expression that you're looking for. It's very difficult. It's not easy. It's not easy to identify which term you need to add and subtract. It really is difficult. So my advice to you is just to practice. And if you get a question like this, this really is a difficult question. All right, so it's much more likely that you'll get a question like this than getting a question like this. Okay, so this is a trick. I'm just going to write that there in case you forget where that came from. Oh no, look at this, which is divisible by A equals B. There we go. Now after this, I don't quite have enough space here at the bottom, so I'm just going to squeeze it in. Therefore, true for n equals k plus 1 if true for n equals k. Since true for n equals 1, then true for n equals 2, n equals 3, etc. Therefore, true for n element of natural numbers. Okay, so these ones are quite tricky. I'm going to give you one of these to try on your own. If you can't manage it, I mean one of these difficult ones and then a few easier ones. If you can't manage it, it's not the end of the world. Okay, I don't want you to stress. It will be okay. I'm going to just circle the ones that I want you to do on the exercise when I send it. So I'm not going to write it down. So just the circled ones are the ones that you will have to do. Right, I hope that that makes sense, guys. And please let me know if you have any questions. We won't be doing a Zoom meeting this afternoon because I think everyone's so busy catching up. We could possibly have one tomorrow afternoon. Just let me know if you need one. All right, so I'm not going to schedule one unless people message me to say that that you need help or that you need one. And in that case, we could possibly go over the homework examples. Otherwise, on Monday, I'm going to post new work, and then we could possibly have a Zoom session on Monday afternoon between 1 and 2. Okay, just let me know what you guys need, and I am here. All right, have a lovely weekend. Thank you.